to go over a few housekeeping things. Oh, this meeting is going to be recorded. Now you know. So materials for tonight can be found in Kaelen's GitHub repository here if you haven't found it already. There are a few R packages that you will want to install if you want to follow along with her tonight. So they're here. They'll also be in her repository. She'll tell you what packages to download. And if you're new to Our Ladies, it is a worldwide organization with the mission of promoting gender diversity in the R community. It was started in San Francisco in 2012 and now has 197 chapters and more than 78,000 members globally. This changes constantly. Every time we have one of these meetups, it keeps growing. So it's constantly growing. You can check out ourladies.org. They have a shiny dashboard, which we're going over tonight, that they built. And so it constantly updates with the new numbers. It's really cool. And this is just a picture of some of the R Ladies from the R Studio conference in January 2020. Janine and I were there. Kaelen was there.
I'm somewhere in the background of that picture.
Yeah, this was pre-COVID. It was right when it started hitting.
The last thing I did before COVID was go to
Exactly.
Oh yeah, you will need Skimmer. Sorry, someone said in the chat. You might want
also Skimmer. Okay.
It's in the R Markdown file that I use to just explore the data. I use Skimmer. So
cool.
But the actual app doesn't use it.
So Our Ladies St. Louis specifically was started in 2017 by Janine Harris and Chelsea West. Janine is on this call, I believe, right now. Chelsea West dropped off because she had just too many other things going on in her life, but she was a founding member. There were 4 meetups when they first started in 2017, 2018. And then we kept growing, 5 meetups in 2018-19, 5 in 2019-20. And then this year, so far, we've already had 4, and we have 4 more scheduled for the spring. So we've grown a lot. So our current co-organizers are Janine Harris, who's on this call, I believe, Mary Painter, who was the one telling you she's going to be answering chats, Shelly Cooper, who I don't think joined us tonight, but she has been a host in previous meetups, and myself, Crystal. So this is our 2021 schedule. We've had a talk on cleaning messy data. We've had a talk on intro to data visualization. We had one last month on intro to network analysis. And then tonight we have intro to Shiny with Kaelen Medeiros. And then our spring schedule is being finalized. So as soon as we know more about that, we will be posting that on Twitter and Meetup and all that kind of good stuff. And then please, in the future, if you want to attend these, just RSVP on Meetup. That's how you get the link to the Zoom and all that good stuff. We are recording, as you heard, this meeting tonight. So if you're uncomfortable being recorded and put on YouTube, feel free to turn your cameras off. And then make sure to just use the chat to ask questions. You can either ask directly to the whole group, or you can ask directly to the hosts, which for tonight are just Mary and myself. And then we will make sure to interrupt Kaelen and give her the question. If you want to learn more or get involved in Our Ladies, you can go to ourladies.org, like I mentioned earlier. And then these are the ways to connect with us specifically. We have a Gmail, we have a Twitter account, and we have a Meetup account. And then last, about our speaker tonight, Kaelen. She's a data scientist at Medidata Solutions, where they work as an R programmer on the microservices team. Kaelen has an MS in Biostatistics from LSU Health Sciences Center. Kaelen has worked at Spring Health, DataCamp, Here Technologies, and as an R and Shiny consultant. And most importantly, they have a black cat named Scully and enjoys podcasts, aliens, nail polish, and data. All right, I'm gonna hand it over to Kaelen.
Awesome. I'm very excited to be here. I have actually been to St. Louis before. Not always true with these digital meetups, but in the mid to late aughts, I was in a medium popular drag king troupe, and we came to WashU and did a performance and a gender workshop at WashU for their LGBT center. So I have actually been to St. Louis and I really enjoyed myself. I was there for a long weekend. Okay, so are you all seeing my screen with my slides? Great, because I have a couple screens. So I wanted to make sure. Awesome, okay. Well, I'm gonna go through a handful of slides. I'm gonna do a combination of slides and live coding. We're actually gonna live code an app together. So let's get started. So we're all here to talk about introduction to Shiny. So like Crystal introduced me, I'm Kaelen. You can find me on Twitter, Kaelen_Medeiros. I deeply apologize that my name is so hard to spell. I've been saddled with so many vowels, but it is in my little Zoom name. And then you can find the slides and all the materials either at my bit.ly link or at the direct link. My bit.ly naming standards have gotten so long that you might as well just go find my GitHub. So anyway, there's Scully in the flesh. You know what I look like. I currently live in Astoria in Queens, so that's in New York City. And I'm a data scientist, like we said, on the microservices data science, data engineering team at Medidata Solutions. They're a company that does clinical trials software. I work on a product called Detect that uses like hierarchical clustering and other statistical methods to find anomalies in clinical trial data. Just helps, you know, investigators when they go to submit to the FDA. We're working with Moderna, for example, on their COVID trials right now. So that's been our big project for the last few months and will continue to be. Like we said, I have an MS in biostatistics and I really love our data aliens, cats, and podcasts, all of those things. So feel free to come talk to me about those after. So here's just a brief outline. We're going to talk a little bit about what Shiny is. We're going to look at the basic Shiny app that our studio provides and talk about the elements, a UI, a server, and some basic reactivity. And then we're also going to build an app together with some St. Louis specific data that I got from the St. Louis Open Data Portal. And we're going to cover inputs, outputs, layouts, and interactivity. It's going to be a really basic app, but it should give you the building blocks to hopefully start building more complicated apps if that's what you would like to do. So let's talk about what Shiny is. So Shiny is straight from our studio, an R package that makes it easy to build interactive web apps straight from R. And they have graciously brought Shiny to us. What that really means is that it allows us to use R code to build these web apps without having to know HTML, CSS, or JavaScript, though some knowledge of those things, or at least the ability to Google and find little snippets of those kinds of code when you want to change things, can be really helpful. Sorry. So I had linked to the Shiny website, and one thing I definitely want to show. So our studio has a really great website, which is one of my resources I link to. One of the things I love most about it is pretty much everywhere on this website where they show you an app, they also give you the code to build that exact app. So one thing I wanted to show specifically that I always use when I'm building a Shiny app is the RStudio gallery. So first, it has a bunch of really cool apps that people have built. They've been running contests, our studio, for the last 2 years to build cool Shiny apps. But once you kind of scroll, I mean, obviously go look at those. They're all really awesome. But when you kind of scroll past that down here in Shiny demos, there's a lot of, like, sometimes I just forget really basic stuff, you know, because if you just don't do something for a long time, you kind of forget it. But it's like riding a bike. So I'll come back here and I'll look at, okay, how do I do like a drop-down selector and make it affect the data in a certain way? I can go play with this app and see the server and UI code. And we'll talk a little more about, of course, what that means in a second. So I definitely really recommend the Shiny gallery. It has all of these, like, if you want to remember how to do or see an example of dates and date ranges, how to do data tables, etc. There's a lot of really awesome examples here in the gallery that I find just like absolutely critical to my own Shiny app development. So let's talk a little bit about how to create an app. I have a slide about this, but I'll also just show you how to do it. So when you want to create a new Shiny app, you can go to RStudio. And of course, my slides have the screenshots, but I'll show it to you here live. You can see my screenshots have the theme I usually use for our studio, which is Fairy Floss. It's in the RS themes package, just as a pro tip. It extends a bunch of extra themes you can use, but I switched back to the standard theme. When you want to make a new Shiny app, the nice thing is that they've made it really, really simple. File, new file, Shiny web app. Then you have the choice between a single file, so one app.r file, or you can do a UI or server file, so 2 separate files. This is up to you. This is a personal preference. Lately, I build multiple file apps because I just feel like when you're going to write really long apps, I like to have them separated. Although really when you're going to write really long, lots of code apps, you're probably going to modularize your code, which we're not going to cover today. So you give it a name, have a directory, and the nice thing is it will create, so we have our example app folder, you can see. It creates your UI and your server file, and you can see they automatically give you, they link back to their website. They tell you you can run this app. We already have some code. So this app right out of the box is actually going to do something. So to start it, we can either hit the run app button, or just as a fun pro tip, if you're clicked into the UI or server file, I'm on a Mac, so you'll have to translate this if you're on something else, but Command Shift Enter, or what is it? My fingers just do it. Oh, my app isn't stopped, that's why. I'm pretty sure it's Command Shift Enter. Okay, never mind. I was gonna be cool, but it's not gonna work. There is like a keyboard shortcut. If someone remembers it, drop it in the bar for me. Okay. Oh no, have I already borked my example app? Things happen. Okay, well, I killed my example app too fast and now it won't let me pull it up. But what it has, I think I have screenshots of it eventually, is the default app has the old faithful geyser data and allows you to select the number of bins in the histogram between 1 and 50. And here you can see, blessedly, I wrote down my tricks. It's, if you want to, you can either hit run app, or it's Command Shift Enter on Mac, or Windows Shift Enter on Windows. And run app is usually in that upper right corner of your script pane. So let's actually look at some of the code for this app. A Shiny app has a UI file. And so here's our UI file. And we can start to get an idea of maybe some of the elements that are in this app just from the function names. We have a title panel, old faithful geyser data, sidebar layout, sidebar panel, main panel. We're outputting a plot. We have an input function. So we know this app probably has 1 output, 1 input. Then we're going to have a server file. In our server file, here's where we actually create the output. This is the actual histogram. And if we were using just one app.r file, there would also be a call to Shiny app that would run the application. But because I use the dual file, you don't actually see that in the example app. So let's talk a little bit about what these things actually are. So the UI is the user interface. So this is the part of the app where you're going to control the things the user is going to see and interact with. So here's where you're going to put code to display your inputs, your outputs, any layout changes you want to make, like tabs and colors. Basically anything that will affect how the app is going to look to your users is going to end up in your usually going to end up in your UI file. Your server file and your server in general is going to create a new environment every time you start the app. And the server function requires 3 arguments, input, output, session. Those are already automatically in there. And in the server, you might want to access those inputs you've created as needed to create all those things you're going to display. This is where you create your plots, tables, your maps, your value boxes, and more is back here in the server file, like I had shown. And then I just want to like really basically talk about the idea of reactivity. So fundamentally, reactivity just means that when your inputs are updated, they're going to automatically update any connected output. And then there's a distinction here. A reactive source is that input itself. The reactive endpoint is that thing that gets updated by the reactive source. and will appear to your user updated. And so these really basic ideas will allow you, when you get a little deeper into Shiny app programming, you can use these ideas to build reactive expressions, which are functions that are only going to be evaluated when called by a reactive endpoint inside a render function in your server file. And they're only evaluated when some reactive source changes. So someone changes an input, and then that backend reactive endpoint code will update. Otherwise, nothing really happens there. If you change a different input, well, that one's not going to get updated because you didn't change that one. So let's talk about the app we're going to build. Pretty excited about this. The last time I did this workshop was for Our Ladies Tunisia, and they had asked me to use some data that was specific to Tunisia. So I kind of took the same idea and ran with it, and have decided to use, like I said, some St. Louis data from the Open Data Portal. Now, unfortunately, there weren't a lot of data on the data portal that were in CSV format, which was just my preferred format for building this app. And it was both, we're in CSV and also we're only in one CSV. I wanted to use the plumbing data, but it was a bunch of different CSV files between 1992 and 2020. And I was like, I don't want to deal with this. This isn't a workshop about data manipulation. So I ended up using the St. Louis excise establishments data set, which just means establishments that hold or have held liquor licenses or permits within the city, partly because I thought this was funny, because at the beginning, if you were here, I mentioned that I don't actually even drink. I love bars. I love going out back when there was a world to go out in, but I don't actually even drink. So I enjoyed this. I thought it would be fun. And so we're going to create a few graphs and a data table of the data in our app. And this data has, it doesn't actually have that many columns. So it has the business's name, the case number. So that's, the case they filed with the city. DBA stands for doing business as. So it's just the difference between if there's, a corporation that owns something doing business as something else. The actual location, I'm pretty sure this is the actual address of the establishment. The neighborhood, there's a police district, when last updated, which I just assume is someone's idea of terrible data management, where they just update these with no, hopefully someone's version controlling this. I don't want to at the city government of St. Louis, but it did make me cringe a little. Status code, so just, how is that liquor license active? Is that establishment closed? And then the ward. And I just grabbed this data, like I said, from the actual St. Louis website. You can get it there at this link, or it is in the repo already. So we talked about inputs. Inputs allow your user to input a value that's going to control the outputs in some way most of the time. Then this is where I kind of point back to the shinyWidgets gallery, which displays a bunch of possible inputs. So checkboxes, date range selectors, entering numeric or even character text, select boxes, sliders, stuff like that. Inputs in general are going to create it with some kind of input function. And one thing I'll note about Shiny right out of the gate, that as someone who uses tidyverse a lot, you got to get used to the fact Shiny was built, all the functions are camel cased. So you've got to switch your brain back over into camel casing. So it'll be text input, all one word, capital input, numeric input, etc. We're going to create our outputs in the server, and you'll see all this in a second. Here's an example. If I was going to make a histogram of the miles per gallon in the empty cars data set, I would output MPG plot. I might have used a better name, but here we are. Render plot. So this is just going to be a static plot. And then you can see, if you're familiar with tidyverse style using ggplot, this is normally how you do that. I did compress it all into one line for the sake of the slide, but you get hopefully what I'm trying to do. And you create this output object, and then back in the UI, you're going to use the correct render, you create the output object with the correct render function. You write code inside of there to create what you want to display. Then you go back to the UI and you display the output with the correct output function, plot output, table output, text output. So hopefully pretty straightforward once you get used to it. We're going to build an app that's ultimately going to look like this. Each of these are different tabs that are going to be a different thing. These two are graphs. This is going to be a data table. And we're going to have 3 inputs. Ultimately, these are going to be interactive graphs and interactive table, but we're going to do it step by step. So let's get started. So I'm going to switch to live coding here in a second. So we're going to use, if you want to just use the files I've already built, you can go to the GitHub repo. The way that I did this in the repo, just to kind of explain it, is each step of the app we're going to create is a completely separate app, and they're labeled like STL app. The first one is static_1, and then usually, so it'll be STL app, the thing we're doing, and a number. And then that way it's just a copy of the previous app. There'll be at least one thing added on. And like we said earlier, you're going to need Shiny, Tidyverse, Forcats, shinythemes, DT, and Plotly. If you're going to use my R Markdown script where I explored the data a little, which I mostly just included for transparency, that was me just playing with the data and getting used to it, I do use Skimmer, which is a really cool package for kind of seeing a picture of your data. Okay, so let's do it and hope that my RStudio works, shall we? So the first thing I wanted to do was add a title to the app, build our first input, which is going to be this drop-down selector for the order of the bars in the graph. I'll show you the graph first so this makes sense. And then a static bar graph of the status of these exercise establishments. And I managed to shoehorn in some bonus data manipulation tricks here. We're going to use the Forcats package. That's where that's going to come in. And I took these tricks from a really great talk given by Dave Robinson that I've linked to here in these slides that he gave at the DCR conference last year about 10 tidyverse tricks he uses for data manipulation all of the time. And I actually used to work with Dave, and I can personally attest to the fact he really does use those tricks all of the time. So let's get started app building. So I'm going to make another new app. So file, new file. And you're welcome to code along. Please, I'm going to try to go slowly, but let me know. Shiny web app. I'm going to call this one live app. And after the workshop, I will push it to GitHub, so it'll be there for everyone. I'm still going to do a multiple file app. Again, up to your personal preference, but that's the way I like things to be. It automatically opens my UI and server file. But one thing I know I want to do right off the top here is I'm going to take my excise establishments CSV data, which I already have in my bigger repo, and I'm going to go more, copy to, and I'm going to copy it to my live app folder because I'm going to want the data in that folder so that the app can actually source that data. So probably the first thing I do when I start a new app is I clear out all of this. Like obviously I appreciate it. I love the RStudio help stuff, but I have to clear it out for my own sanity. Yeah, anything that's like specifically about the Geyser app, I just get rid of because I hate it. Then let's actually look at this example app since I couldn't show it earlier. So the example app, the default, you can see it has the title that we saw in the UI file, Old Faithful Geyser Data. And then, like I said, you can select the number of bins, and you can see how when I update the number of bins, my histogram of this Old Faithful Geyser data updates. So this is pretty basic app. This is a static graph. When I hover, I don't see anything extra. In fact, they just use base plotting. It's just a base histogram. So I am going to first change the title. I think I called it just STL excise establishments, but you know, feel free to use a snappier title, whatever floats your boat. I will say, and again, this is all personal preference, I don't usually fully clear out all of the default stuff. I tend to replace it all one by one because when I do try to clear all of this out, I tend to accidentally delete important parentheses and end up in parenthesis hell. So I don't usually do that. So I'm just going to rerun the app just to see if my title update worked. And it did. So it's no longer Old Faithful Geyser data. now it's that. So if we go back and look at the screenshot I provided for you, let me show you the graph we're moving toward. So we're gonna build a graph that I swear I have built somewhere here. Oh, you know what? I don't. I did this with something else. Let me real quick build it. Status code. Okay. So we're going to build a graph in the app that looks like this. So it's just a bar, just a bar or a call plot with counts of the different status codes. So one thing I thought could be cool, and you can see this is where I'll talk about my forecast trick, is if I take that out, you'll see that the default for this graph is, of course, what you may know about ggplot graphs is that it will plot these in just alphabetical order: active, canceled, closed, open, renewal. So I thought for the first input, it's almost like we're building our own like data exploration software. I thought for the first input, we could build a drop-down input that would allow the bars of this first graph to be put in either alphabetical, ascending, or descending order. So first we have to figure out what kind of input that is. One way to do that is you can go to the gallery and scroll down and start to kind of look at inputs. I, of course, know that I want this to be a select input, which is what they call the drop down. So I'm going to pull up the health page for select input so I can remember how it works. Okay. So when you build a Shiny input, let's put a select input in here. I'm going to replace, just so you can see that again, I'm going to take this slider input. I'm going to carefully only select the slider input, and I'm going to replace it with a select input. So there's some really critical things that an input has to have. First, you need the input ID, and this is the ID you're going to use to refer to the input in the server. So I'm going to call this bar order, but call it what you will. Then you're going to want to label, and you can do these. I'm at a point in my Shiny development that I don't do them as named arguments, but you absolutely can. So we could do it as, just to keep things straight, I'll try to name the arguments today. Input ID, bar order. Label is the thing that your user is actually going to see. So they're going to see this text that I put here. So I'm going to make it say, select the order for the bars, which is just like a pun, I guess. So you're welcome. I'm really truly making this up on the fly. Then what we're going to need for a select input, what's really critical, is we're going to need choices for a select input. Well, one thing we could do here, because we have the excise establishments data like available to ourselves, is we could do, STL. I have it called STL excise establishments, status code, and we could just unique it. So that's what it would look like. So for now, I'm going to do that as my choices. And let me show you what this looks like, and then we're going to go do something different. But I do want to show how this updates so you can kind of make the connections. Oh, why are we mad? Oh, because I named the argument wrong. Don't be like me. Okay, so this is now erroring because we replaced that old input. So that's normal, ignore that. But you can see that label that I used, select the order for the bars, is there. And right now it's all of those things, but you can see that because the data is this way, they're screaming at me in all capital letters. And if I had it my way, I would never use capital letters. So we're going to do something else. We're going to use that call to unique STL establishment status code. This is how I do this. I'm going to copy those. Then I'm going to make a vector up here in choices. I'm going to add my commas. This part is like sort of tedious, but this is real shiny development. It's so thrilling, is it not? One really cool thing that we can do with the select input is we can instead do closed equals closed and just title case it. And then the first thing is the thing the user will actually see. And then in the actual data, like if we're going to use this to filter the data, which spoiler alert is eventually what we're going to do. Sorry, what am I doing? Why did no one stop me? The order for the bars is, I'm completely ahead of myself. Forget everything I just said. Is alphabetical, ascending, and descending. You couldn't have known that. Cool. We're done. That's this input. So let's actually look at it again. We're going to repeat all that stuff in a minute. Great. Love that. Happy about it. If you want, now the order of the choices, the first one is what's going to automatically display to your user. If you want a different choice, just put it here. I'll show you what this looks like now. Now the default should be, if I had done this correctly, well, again, if I had named the arguments correctly, you can see that I never name my arguments. You can see now the default is ascending. So you can control that default. I'm going to leave it just as alphabetical. We should probably actually create this input though. So let's switch to our server file. The way you create an output is you're going to do output $, and then you're going to name it. So I'm just going to do output $, status bar plot. I tend to kind of revert myself to camel case when I do shiny development. I'm going to clear out that stuff. I don't need it. But of course, one thing you might be asking yourself is, Kaelen, how does the data end up in here? Great question. So we need to actually make the data available to ourselves. So I'm going to do that here. I'm going to do the same thing I did before, where I'm going to call it STL excise establishments. Then you might load, is it tidyr? You're seeing me be bad. I don't use, so it's readr, not tidyr. I'm going to use read CSV. And then remember, this is why I had to stick the excise establishments data in our live app folder, is because now I can just do excise establishments.csv, and that'll make the data available to our to the app. One thing I'm going to do for myself that is truly optional and would require you to have the janitor package is I'm going to use janitor clean names. So this is because in the actual data, if I actually just do this, the data names are all in caps like the rest of the data, and I hate that. If you use the clean names function instead, it'll snake case all of your names. So that's just a me tip, doing things that make me happy. So we should probably build this bar graph. So first, let's just build it. We have our STL excise establishments. We're going to count status code, which if you haven't used count before in dplyr, let's call it explicitly. No, I'm actually going to load dplyr. I usually load dplyr in apps, but most things I call explicitly. In general, especially if you have a really big app, you want to keep the amount of packages you're loading with the app minimal, so you can make explicit calls. You'll see that I'll do that with things like readr, janitor, later plotly, and DT. dplyr I'm just going to load because I'm going to use it so much. And I'm going to load ggplot2 actually in the app in this server file because I'm going to use those so much. I'm going to want to have them. So we're going to make that same plot from before. So we're going to do ggplot AES status code n plus geom call. Okay. Now, if I ran the app right now, even though I've written all this code, I'm still going to get that error. Well, I'm not going to get the error because there's no error to get anymore, but I don't have anything here. And that's because, like I noted in the slides, I have not gone back to my UI file and in my main panel done plot output. It still says dist plot. So if I change this to status bar plot and now run my app, there it is. Very exciting stuff. So we have it, and of course we have the default here, the alphabetical. So active, canceled, closed, open, renewal. But the way we want this to be is, again, almost like a Tableau, like a Looker, like your point and click data software. I've never used either of those things, but I know they do things like this. We want ascending or descending bars. So ascending just based on like the counts. So we're gonna have to make this do that. So one thing I'm going to do, just because of, don't repeat yourself, because I know I'm going to do it a bunch of times here, is I'm actually going to call it by status code, which is definitely a Dave Robinson thing if you're familiar with his live streams. And I'm actually just going to save this little data thing by status code that counts those statuses for me. So that's great. We're pleased about that. So now we could pipe by status code into our ggplot. And just so you know, the shortcut for properly indenting your code, if you don't know it in RStudio, is a Command I, or the Windows equivalent. Life-changing. So one cool trick that I learned from Dave is if we want to put the bars in a certain order, we can mutate the status code variable. We're going to use forcats. We're going to use, this is just like a bonus thing. It has nothing to do with Shiny. We're going to use one called FCT reorder. Let me bring up the help page for that so you can see it. And FCT reorder from forcats allows you have to pipe in a fact, or whatever, I'm using pipes, a factor or a character vector. And then you can reorder the levels based on another variable in the data set, based on a function, mean, median, all that jazz. So I'm going to reorder the status code variable by n, because that's my count that I have in by status code. So now let's look at the difference. Again, we haven't connected the inputs, but let's look at the difference in the bar graph. Now it's ascending, I guess. I really do truly confuse those. So I may have confused them in the version of the app on GitHub. We will all have to forgive me. So that, and then there is a fun, I guess that's ascending. I should look at the arguments, because if I do dot disk, which is the way I always pronounce it in my head, is true. Sorry. Then you'll see that now they're descending. Truly a fancy, fancy data manipulation trick. Well, I'm not a super fancy person, so we're going to do this in an if else. So the way I'm going to do this is we have to access that input that we created. So we should go back to the UI. Remember, we look at the input ID and we saw that we called it bar order. So if input $, and luckily RStudio is so smart, it'll show up for you already. So I have if input $, bar order equals ascending. I'm going to start with ascending. Then I'm going to take my code, I'm going to copy this, and I'm going to turn off the disk equals true. Now I'm going to else if. This is just, what a fancy person I really am. I'm sure you can feel it. Descending, and I'm going to copy this exact code. Then, well, let's do the else, and then we'll go back and do the thing I forgot to do. Otherwise, we're just going to take out this mutate. completely, and then it'll just be that alphabetical bar plot. What we also should have done in here is we need to assign it to an object. You'll see why in a second. So I'm going to go back and add this assignment in each if else. I'm just going to call it status bar plot. And that's so I can out here return status bar plot. And I'm going to add labels with the labs function, if you're familiar with that in ggplot2. So my X label, I think is going to be status, and Y is number of establishments, because I did not chord flip. Okay, so now I'm going to run the app and see if I've done anything incorrectly. You'll find out fast, promise. Okay, so if we make it a little bigger, let's see if we switch one of the inputs if something actually happens. Oh my gosh, I'm so excited. I get excited every time, I swear. This is like, I'm being real. Okay, so we did it. We added a title. We have an input that allows us to change the order of the bars. And we've got our count here of number of establishments. I love this. I think it's great. I think it's super cool. Let's build one more thing, and then we can maybe take a little break, because I think we'll probably be close to 8. So the next step, and I've labeled these slides with what the folders are called on the actual GitHub repo, if you're looking there, is in the next step, I want to actually add that tab layout. So you saw maybe in my screenshot, sorry, my internet is starting to glitch. I'm getting very slow. You saw these tabs. So these are actually clickable tabs. So we're going to actually add that tab layout. We'll add a slider input, this slider input to select the number of neighborhoods to display. You'll see why in a second. A checkbox input to select the statuses to display. You can see that was why, this is where I got all this when I got ahead of myself. That was a spoiler for this checkbox group input. And we're going to do another data manipulation trick. It might be the same one. No, it's a different one. Ha. We're going to do some more forcats data manipulation that actually I might have to look back at my own code for, and we're just going to have to forgive Kaelen that. Live coding is stressful. Okay, so we'll start with the tab layout. As you might expect, the tab, anything that affects, again, the way that an app looks, we're going to do back in the UI. So we've got to flip back to the UI. When we look at this actual screenshot, you might see the tab layout, and I didn't really hammer this home at the beginning, but this is the sidebar, and then this is that main area. So that corresponds to the sidebar panel and the main panel. So we want to add the tabs in the main panel. I always have to look this up before I do it. I don't know if I've ever built an app and remembered how to do this off the top of my head. So don't feel bad. The nice thing is the help shows us an example, which where would we be without really great documentation? So you can see here in the help that the way you're going to add a tab layout is we're going to have to, down here, I'm going to just space for a little bit so we've got some space to work. We're going to need to add a tab set panel function. That just says, hey, I'm going to add some tabs, but it doesn't actually add any yet. To actually add a tab inside of tab set panel, we have to add a tab panel. The tab panel has two key elements. The thing that the user is going to see that the tab is called. So I'm going to use status bar plot. Then your actual output. So I'm going to go copy that plot output that I just chewed out of the way and put it back inside that tab panel function. Okay, so we've only have one tab, but let's actually run the app, which if you haven't noticed is something when you're doing Shiny app development, you're just going to continuously run the app and see if things are working. Ah, beautiful. So we only have one, but look at that. We've got a tab. I feel good about that. I'm excited because now I know I can add more tabs. So for our second graph, the way that the thing I decided to do for the second graph is I thought that we could do, it's going to be a little more fancy than this, but I'll show you the rough version. We're going to do counts of neighborhoods. We're going to use FCT lump. We're going to choose the number of neighborhoods we want to display. We're going to use forcats FCT lump to create an other category. That'll be cool trick I'll show you. And then we're going to take this one step further, and we're actually going to color by status code. So thrilling and exciting, I think. So first, let's build the slider output because it's actually not too bad. So I'm going to look up the help for slider. It's a slider input. I just said output, so ignore me. Okay, so let's look that up. Slider input. So we'll go here to our select input. We'll put a comma. We'll go down a line. Slider input. Now, every single input is always going to have an input ID, which I'm calling this one number neighborhoods. I'm going to call it number of neighborhoods. That'll bother me. And then my label, which again, that's the thing our user is going to see. So choose the number of neighborhoods to display besides other. You'll see why in a second. Then in general, what you're going to want for a slider input, your min, a min value, which in our case is 1, a max value. I think I arbitrarily chose 15, it looks like, when I made this app the first time. Value, you might want to choose the default value. I chose 6. And in the cases where you have, I think the default step is just going to be 1, like an integer. But if you have decimals and stuff, you might want the step to be a half or a tenth. I'm going to set it to 1 just to be really explicit. Okay, so let's run the app and see the addition of our slider input. Ooh, she looks good. I like that. It doesn't do anything yet, and that's fine. So let's actually build the bar plot and make that input do something. But this is the part where I absolutely have to go look at my own code, which I apologize for. Okay. Great. Love that. I did a great job. But I can't remember it right now. Okay, so I'm going to put a comma after my first input, my output status bar plot, and I'm going to create a new output. So I'm going to do output $, because I am not creative. I'm going to call it neighborhood bar plot. Then I'm going to use the same function, render plot. And then this is kind of a shiny thing. You do parentheses, then you also do curly braces, and then open that up. So you can see that I did this up here too. Oh, you don't need that comma between, I don't know what I'm on tonight. You don't need that comma between outputs. Please delete that. It was probably showing you the error. Might be. Okay, so we have our STL excise establishments data. Again, because this is not a workshop on data manipulation, I just filtered out anything where the neighborhood name was NA. I was like, I don't want to deal with this. I gotta move on from that. So one thing I promised here was that we'd use, well, first let's just build the input as it's going to be. So can we do that? Yeah, we'll do it. No, let's do the thing. Sorry, guys. Let's actually mutate and change neighborhood name. So here was where I promised that we're going to use this really cool forcats function called FCT lump. So let me pull it up. What FCT lump does is it'll take your variable that you pass in. We're going to give it that number from the input, and it's going to create, like you saw in the plot, it'll create the number that I give it, which here was 12. So I've got these 12 neighborhoods, and then everything else just gets lumped into an other category. So it's nice when you've got a factor with a lot of levels where all of those things where it's really small kind of probably don't matter, because what it selects here are, I think it goes in order of like it selects the highest value and then it just lumps everything else into other. And the neighborhoods here, there's quite a few levels of these neighborhoods. So if we look With count, we can see that we have NA is the biggest one. And again, I got rid of those, so let's not worry about that. But you can see that besides NA, we have these 9, and then we have 69 more rows. So like, I don't want to build a bar plot that displays all of those. So I'm going to use FCT lump. Let's go back and look at the help. The way that you have to pass them in is, ooh, I don't like this documentation. I'm gonna talk to somebody about this. We're gonna pass in the factor and the number that we want. So we're gonna take neighborhood name, and we're gonna adjust it by our input number of neighborhoods. So we like that, that feels good. Then I will narrate this, but I am gonna go steal my own code for a time. Then we're gonna do ggplot, AES. First, let's not worry about this. Let's do, oh, I called them, we'll do neighborhood name. Yeah, we're gonna fill by status code. We have a geom bar. I'm gonna flip the coordinates. This is, you can see that I did this here. I flipped and put my factor on the Y. And then I added my labels here. So let's run this and actually look at it and see if we did anything wrong, which is, oh, well, I'm not displaying it yet, so we don't know yet. So let's add another tab, shall we? We got to go back to our UI file. We're back inside of tab set panel, and we'll add another tab panel. Tab panel, we'll call this a neighborhood bar plot. Feel free to use much more clever titles than I am. And we're going to do our neighborhood bar plot. We called it neighborhood bar plot, but camel case. So I'll go back and grab that inside of plot output. So now we can actually view it. So now we have 2 tabs. Ooh, it did work. I feel good about this. So you can see right now that we display 1, 2, 3, 4, 5, 6, and then the rest are in other. If we increase that, it should display, now it displays 13, and the rest are in other. But of course, like the last plot, you can see that this is just alphabetical. And I don't know if you're as anal as me, but like that makes me a little bit crazy. So we can do another cool forecats trick back here inside the ggplot. We're gonna get rid of neighborhood name. We're gonna use it again, but bear with me here. We're gonna do forecats FCT in freak, and then we're gonna put neighborhood name inside of that. And then let's run that so that you can actually see what it did. So now you can see, whoop, I like that a lot better personally, that it's now, you know, ordering more. If you want it reversed, so it's other on top, you would just wrap this forecats call to FCT and freak with another forecats, FCT rev. So just reverse. So let's run that. Get a good look at it. I love that. I'm pretty excited about it. And you can see it should update with our input. Kind of takes a second. I think this is my computer right now that's deeply slowed down. Hopefully it is not this slow on your computer if you're coding along with me. Okay, so I think I said for step 2 that that was actually all we were going to do. And that is unfortunate. Oh no, excuse me. I was going to do the status of establishment thing, connect that input. So let's just do that real quick because I think it's pretty fun. So back in the screenshot, you might have seen, and I'm having trouble navigating back to it, but we had all those little checkboxes with the status. Basically, I thought with this app, because we already did the thing on the front where we basically are making our own data manipulation tool where we switch the order of the bars. I thought for this second plot, right now, you know, active, cancel, close, open, renewal, but what if I wanted to get rid of one of those? I can create like a checkbox input here that will allow me to maybe get rid of canceled and closed because I don't want to look at those. So there's a couple different kinds of checkbox inputs. In our case, we're going to want to check the checkbox group input because it's a group of checkbox that, as it says, can do multiple choices independently. The regular one, checkbox input, is just for logicals, true, false. We're going to do a group. So let's look at the help for that. Okay, as usual, input label, and you'll see this actually starts to look a lot like our select input, and that's why I got so ahead of myself when we were building this last time. So let's add a comma, and we're going to add a checkbox group input. Input ID equals status display. Oh, sorry, it's absolutely my computer slowing down. I have everything I don't need closed, but here we are. My label is going to be choose which statuses to display in the plots. And this is where the fancy thing I was doing earlier, where I was doing STL excise establishments, status code, and I uniqued that. And we made that drop down where they were all caps, but I don't like that. This is where I'm going to make my vector. There's absolutely a faster way to do this, but here we are. And then I can do title case closed equals all caps closed. Active equals active. And then the same things here with all of the rest of them. I can make it say whatever I want. So this last one, maybe instead of renewal, in renewal or something, it'll still line up with renewal. And in this case, so let me show you what it looks like now. Okay. And again, my computer is deeply slowing down. Once we take a break, I'll close some more things. So you can see we now have our checkboxes, but by default, none of them are checked. So this is where the selected thing is actually going to come in real handy. If I remember correctly, it has to be the real values, but I should just look, but we're going to do it on the fly. So I added in closed, active, open, canceled, renewal, and now perfect. I want it that way because remember, I want it to affect my plot and I want them all to be there and I want to be able to deselect and get rid of a status. And blessedly, this is really, really simple. We're going to go back to our server and our output neighborhood bar plot. Inside of our filter, status code in, because this is a multi-select. So remember, this is going to be an object that's going to have, by default, 5 selections in it. Input status display. Let's run the app and see if we can influence the statuses that are showing. This should not be taking this long, so I hope it is not for you. Oh gosh, what have I done? Okay, so I'm going to flip to my neighborhood bar plot tab. I'm going to let this load. This is like deeply harshing my reveal buzz. Okay. Now, if I get rid of one, it should go away. And it did, because now I can see in the legend, it's just canceled, closed, open, renewal. Got rid of closed. So now we've actually built all the inputs we're going to build. So we're done with inputs. We're going to build one more output, and then we're going to do some just aesthetic stuff. But since I know this is a workshop, I wanted to give everybody I don't know what you guys want, Crystal and Mary, like a 5 or 10 minute break?
I think 5 is fine. Yeah.
Okay, cool. So 5, I guess for y'all, if you're on St. Louis time, I guess come back maybe at like 7:11. I'm on Eastern time, so it's gonna be like 8:11 for me. But yeah, we'll take a 5 minute break. Okay, so are you looking at our studio screen? Great.
Yes, we see it.
Okay, so for the third step, what I was gonna do is add a table, just a table of the data set. And to start with, I'm gonna do a static table. So I'm gonna create an output. I'm gonna call it output size table. I'm just gonna use render table. So this isn't gonna be fancy yet. Then all I'm gonna do is just put the name of the data set. Just STL X size. We're literally just gonna print the data into a tab. So we're gonna go back and create another tab in our UI. So we'll need a new tab panel. Tab panel. I'm gonna call it STL X size establishments DT. Then I'm gonna use table output with my name, X size table. And hopefully you've made the connection, even though I don't think I said, I think I said it a long time ago explicitly. Render table, table output, render plot, plot output. They really did line those things up for us. So let's run the app and see what happens. And I did look at my activity monitor, and Zoom is just like eating up my computer. So that's why everything's moving so slowly. I'm choking on tea.
Are you okay?
Yeah, I'll be fine. It was probably the way I was destined to go anyway. Trust me, it'll be something really embarrassing. I'll probably win a Darwin Award someday. You'll see. So I'm going to click over to the excised establishments DT, which of course it's not actually a DT yet. I'm just giving us all a spoiler. And it's going to take a minute to load here, but you can see now I've printed the entire data set into this tab, which is like cool, but not that useful. Because like I can't filter this or sort this or really do anything with this. So like the table's nice, but we basically, like if you're familiar with our markdown, we basically just like knitter cabled it. Like it's not that cool. It could be cooler. So let's move on to step 4, which is a cool step where we make everything interactive. I like step 4. So this is where we're going to start using some HTML widgets. So if you're not familiar with the HTML widgets package, it's what powers us to do a lot of like web app type stuff in R. So we're going to use specifically Plotly for our graphs and DT for our data tables, but there's a bunch of things. If you're going to make a map, you might use Leaflet. All sorts of cool HTML widgets. So we're going to do some converting. That's kind of the nice thing here, is that this isn't actually that hard to do. So let's start with the plots. Let's do the first plot first. Instead of render plot, we're gonna switch this to Plotly. We're gonna use an explicit call, render Plotly. We do need to do one more thing with a Plotly. Ooh, my computer is throttled. So we're gonna do one more thing here. I think, no, I don't actually have to do this, never mind. Okay, then we'll go to the UI and we'll change plot output to Plotly. Plotly, and we'll spell things right. Output, and we'll use 2 colons. So let's just run that so you can at least see it. And you have to save all the files. That's one thing our studio requires. Everything has to be saved or it won't actually run your app. And even if I had made changes to this, which was my app, it was
Hi, Kaelen. Can you hear us?
Yeah, I lost you for a second there, so I stopped sharing so that you can.
Okay.
Yeah, again, it's Zoom. Like for some reason tonight, it's just like throttling this computer. I probably should have done this for my work computer, which is newer. So I'm gonna close a couple things.
Great.
And then share my screen again and just see if we can make this work. Okay, I'm gonna close one more program that's like not actually mission critical. Okay, hopefully. I'm just gonna turn my camera off. I'm very pretty, but I think it will help if we nix that. Okay, so you can see my screen with the app now, hopefully.
Yeah, it looks like it's running great.
Okay, great. So because we changed all those things to Plotly, now this first, oh, I lost you guys. Can you still hear me?
Yeah, I can hear you.
Okay, for some reason Zoom is no longer showing me you. So definitely speak. No, definitely speak. I can no longer see any of you. Okay, so now you can see that I have now converted this first graph to a Plotly graph. And I can tell because when I hover over it, I start getting Plotly options. And if I hover over this, I can actually see the N. We still can change our order of the bars with our input, but now this is a Plotly graph. So luckily for the graphs, it's truly just as simple as we change this to Plotly output, and then let's flip back to the other graph. And instead of render plot, we'll do Plotly render Plotly. So it's pretty straightforward for the graphs. For the table, we're going to need to do a little more. So for the table, we're going to use the DT package. So there's a data table output built into Shiny. I'm going to explicitly use DT. So bear with me. We're going to use DT render data table. But inside of here, we're going to have to take STL excise establishments and we're going to pipe it to DT data table. We're going to do this because data table. I want the actual data table function. Great, love it. Because we're going to want some of these data table options. So we'll go back to our server. Instead of table output, we'll do DT data table output. Then let's run the app so you can at least see what a basic data table looks like. My kingdom for a data table. So this is just a JavaScript thing ported over, but now you can see that I can now sort these, which is great. I can search, so, delightful, all sorts of cool things, but there's more options we can do. So one of the first things I usually do with a data table is I set row names to false because you might have noticed that they were hanging out there along the side, and I don't want those. You also might notice along the top here that these are, of course, the default name of the variables in the data set. So just like I can turn off those row names, I can create different column names inside a vector. So I can see right here the actual names. So I'm going to create the ones I want. Business name, case number. I'm going to spell out doing business as, because DBA doesn't really mean anything. Location, neighborhood name, police district, and I'm not going to include that last updated stuff because in general, your end user probably doesn't care. Status code, ward. Beautiful. So let's run that so we can get a good look at it and make sure that our changes actually took effect. Ah, they did. So now I see, instead of the default names from the actual data, now I can see the names that I chose. But there's one more thing that I love about data tables that I'm gonna turn on, which is the filter. So I'm gonna do filter equals top. You can either do it at the top or the bottom. So let's see what this did. This is what I love about the filter, is that now I have on the top of every single one, I can actually filter. So if I only want police districts 1 through 3, now I only have police districts 1 through 3. The one thing that actually is super helpful when you have a DT with all these like character variables is to actually convert them to factors. So I'm gonna do, let's see if I remember how to do this off the top of my head. I'm gonna do mutate, mutate if is character is factor. I lied, there was one more bonus data manipulation trick. So, okay, that did not work. So let's go look at my actual code, or somebody tell me what I did wrong, since I've already built all of this. As factor, not is factor. Ha ha ha. We out here, really using the wrong methods. Okay, so now this should be better. Yes, it looks like it did work. So now in the case of, it doesn't make as much sense really for things like neighborhood name, so, or business name, excuse me. So I might actually not have done that like blanket mutate if, but for something like neighborhood name where I know I only have, I guess it's actually 70 of them, but whatever, I might want to look only at the things in Car Square. Now you can see anything that's, and only the open ones, which it turns out there are none, or what have you. Now anything that's a factor, this is a drop-down selector instead of like having to type something in, which is what you would have had to have done if it was just character. So that's one thing I like to do to my DTs. These are usually the things I immediately do to any DT I create is row names equals false. I add my custom call names and I add a filter. I usually put it at the top, but you can put it at the bottom. Ooh, we are so close to the end, y'all. We are, well, the end of what I planned. So, okay, we have one last thing I'm gonna do, which is there's a really cool package called shinythemes. So right now, obviously default, white, 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 not necessarily great to look at, like it's fine. But what if we could just really easily make things better? We're gonna use a package called shinythemes. And shinythemes has a really cool thing called the theme selector. So I'm gonna add this in to, I usually put it right here under my title panel, but above my sidebar layout. This called to shinythemes theme selector. I'm gonna save the file and run the app. And what we're gonna see the addition of is this cool selector in the corner that has a drop down. And if I select things, it'll allow me to preview all these different themes that I might choose. So you cycle through all of them. This is what I do basically every time, is like cycle through like what speaks to me today. It just depends on the day, what speaks to me, to be honest. That's horrible. I'm not going to do that. Let's do paper today. This feels right. I like the way it does the checkboxes. So once you have a theme that you want, so I know that I have paper. I'm going to keep that in my brain. I'm going to comment out the theme selector line and do shiny themes, shiny theme paper. And now my app would be in the paper theme if I had done that correctly. So let's go see how you actually do it. Theme equals, okay, so you have to do theme equals. That's what I forgot. Okay, so I just added theme equals shiny themes, shiny theme paper. Now it's actually in the paper theme. Gorgeous, really beautiful. I'm really happy with this. That doesn't affect that yet. I'm pretty pleased with this, y'all. This is like a good enough app, in my opinion. So the one thing I left, and I think we have time, so I'll cover it at least in theory, and then I'll show you the code. I don't think I'm going to build it for you. Is we might use a reactive expression, and the reactive expression that made sense for me here would be to filter the status codes and make that status code selector also impact that first graph. But of course, it's prudent and it's going to be less expensive computationally to only do that filtering one time. So we might build a reactive expression to do it. So I'm going to close out the live app I built, and I'm going to go to the version that I already built, which is in the on the repo is app reactive expression 6. And I'm going to open these files and just show you what's different. The only thing that's different is in this server. In the server at the top, I did STL status codes. That's what the function is called, reactive. And then I take my data and I just do that filtering, status code in input status codes. So that was that filtering that we did before. But now I've created a reactive expression. So I go into my output status bar plot, and when I create by status code, instead of by status code being created from just the bare STL excise establishments data, I don't want that. I want to create it with the STL status codes because I want to create it with that data that's already had been filtered based on my input status codes. But it can't be bare like this or you'll get an error. I'm going to show it to you just so you know what this error looks like. It's going to take a second to load, but it's going to give us the classic error. So we can't do a group by of a class reactive expression because this is an expression. We can't mutate, we can't group by, none of that stuff. So that's actually a ggplot error, but what it's telling me is I have forgotten to put the parentheses after a reactive function. This is a function. STL status codes is a function, and anywhere that I use it, which is up here, not down there, again, don't be like me. Do what I say, not what I do. Now, if I run this with the actual, my parentheses, now you'll find that, let's reorder these to be descending, but this will affect this one and will affect these because down here in the code for both status bar plot, I switched it to use STL status codes. And for this one, I switched it to use STL status codes and then took out the filtering for status here online that would have been on line, I guess 50. I removed it because now it happens in that reactive expression. So reactive expressions are a good place to do, like, if you know, I think the classic example we used in the course I've written about this was BMI calculations. Just calculate that in a reactive expression and call that everywhere else you're going to use it in the app. Here, I did a data-based example, but in general, reactive expressions are sort of like that, that if you're going to do something a lot, you might as well build a reactive expression about it and just do it really one time. And reactive expressions are actually get so much more complicated, but you're going to want someone way smarter than me to explain that to you. So on that note, one person who might be able to explain it to you, I know I've linked you to the RStudio Shiny website, but one really cool thing that is online right now is Hadley is writing a book called Mastering Shiny. And as he has been writing it, it is online for your feedback, for your perusal. It will eventually, of course, be available as like a print book that you can buy. But like most of his books, it is available online right now. It will explain things to you so much better than I have here today. And I definitely recommend it as a resource. The other thing, just Google. I mean, this is like, if you do a lot of programming, this is maybe obvious, but just like Google everything. When I built this workshop originally, I couldn't remember how to do DT options, and I went to Stack Overflow and it reminded me how to do DT options because I just hadn't done them in a while. I reminded myself shiny themes, stuff like that. So that's the app. That's what we're going to build. I will right now push so that we have it. I will push the live app that I coded. during the workshop to GitHub. So it is now, or in a second, will be there for posterity. And then otherwise, I am happy to take questions, hopefully about like pretty basic Shiny stuff, because I'm not a master, but I do know some things. So I am happy to take questions if there are any. I'm gonna open up the chat myself too.
Mary, should we stop recording now and then have it be a free-for-all?
Sure, we can do that. I guess we can close by saying thank you.
Thank you, of
Yeah,
course.
my last slide I do like to show. You can find me on Twitter, like I said, Kaelen_Medeiros. You can email me, KaelenMedeiros@gmail. I have a website, which I put at KL Medeiros, because I did it years ago. Code and slides. And then this is, I always end all my presentations with this slide, because this is a picture of me and the Robinson family dog. Emily Robinson shares this dog with her parents named Abby. And this is back when my hair was pink and you could go to people's houses, and Abby and I snuggled a lot that night.
Aww.
Is a beautiful, beautiful 12-year-old, just the sweetest dog in the whole world. So I'm a big Abby fan. I have to tell people.
What a great way to end the presentation.
Indeed. So hopefully now we can all build really basic Shiny apps, and then it gets so much cooler and so much fancier. So
sure.
Go for it.
All right, let me stop recording and then we can have a conversation.
Cool.